The next talk is on how to make your Python Jupyter notebook standalone and reproducible to allow other users to replicate your experiments. And the speaker is Maya Costantini. Thank you. And as a reminder, the speaker won't be taking questions after the talk here. You can meet her in the hallway. Thank you.
Hi, thank you. Welcome to this talk. First, to begin with, a few words about me. My name is Maya. I'm a software engineer at Red Hat. I'm passionate about Python and open source, and I come from Paris in France. If you want, you can find me on Twitter and GitHub. And if you want to have those slides available to follow along, you can scan this QR code right here. If I am here today, it's to talk to you about a great project I've been working on at Red Hat for now 7 months, called Thoth. And I want to explain to you how you can use it to make your Jupyter notebook standalone, reproducible, easier to maintain and to share with others, but also to radically improve the quality of your application software stack by choosing the best possible dependencies for your notebook. Before we start, I'm curious to know who of you has ever used a Jupyter notebook? Okay, a lot of people. And who uses this day-to-day for work, for example? Okay, great. For those of you who are not very familiar with Jupyter Notebooks, I can start with a quick introduction. Jupyter Notebooks is an open source web-based application that allows you to conduct iterative experiments and to create documents with live codes, equations, images, graphs, etc. And that supports a wide variety of languages, over 40. They provide a rich and interactive outputs and allow to leverage some big data and data exploration tools such as Spark, for example. As you may know, Jupyter Notebooks are in fact already quite popular, especially in the Python community. Data scientists use them for things such as visualization, data modeling, data analysis, and developing machine learning models. They're also used by academics and by Python developers for things such as rapid prototyping and proof of concepts. So what is the issue with Python Jupyter notebooks? What problems could we be trying to solve? To understand that, let me show you an example. Let's say I'm a data scientist and I want to create, for example, a computer vision application. And to do so, I would like to install the OpenCV library in my notebook. To install OpenCV, I will run the following command in my notebook, which is pip install OpenCV Python to get the OpenCV Python package. Okay, but what exactly is OpenCV Python? OpenCV Python is a direct dependency of my application. And with this direct dependency come other dependencies, like for example NumPy. So NumPy is a dependency of my dependency, which makes it a transitive dependency. So far, I have run pip install OpenCV Python. I got OpenCV Python and NumPy. But did I forget something? What about the versions? Maybe I would like to install some specific versions of my dependencies. Well, last time I checked, OpenCV Python had over 60 releases and NumPy something like 80. And if you take a look here at the release history for a package like NumPy, if you look at the dates, you will see that releases happen approximately every month, which is very frequent. So this means one thing. It means that if today I start developing my notebook by running pip install, for example, NumPy, at the start to install NumPy in my notebook, and that I run this notebook once again in 1 month without specifying any version either, I will probably not have the same version of NumPy installed in my notebook. So this is an issue, of course. And also, what about hashes? Hashes are a way to guarantee the provenance of a package and to make sure that an artifact that you use in your application has been installed from a trusted source of your choice, like, for example, an index. Specifying hashes to identify the provenance of your dependencies is essential if you want to share your notebook application in a more secure and reliable manner and allow users to install packages from the same sources as you did. But also, what about the Python interpreter version? Every Python interpreter version is different, and your notebook will not necessarily be compatible with all Python versions. So this is an issue, for example, if you used your notebook, if you developed your notebook using Python 3.8 and you share it with someone who uses Python 3.10, maybe this person will not be able to run it properly. So we have issues with versions, with hashes, with the Python interpreter versions, but can we think of something more? In fact, a Python application is composed of many layers, and each one of these layers has the power to potentially break your code. On the top layer, you have your Python application code, and this is really the only layer you really have some control on. For example, if your code is broken, you can still have a fix for it and propagate this fix to other users, and they will be able to run the code as well. But below this layer, as we saw earlier, you also have Python direct dependencies, transitive dependencies, the Python interpreter you use, but also other things such as native dependencies, like glibc or CUDA, for example. You have also the operating system you use to develop your application with different kernel modules. And finally, on the bottom layer, you have the hardware with different CPU and GPU architectures. This is why using the simple pip command to install your dependencies will not help you achieve the goal of reproducibility you would like to have for your notebook. So to summarize, if you do something like this, which is pip install your dependency without specifying any version or hashes, it will not guarantee any reproducibility for your notebook. And maybe you would think of doing something like that, which is specifying a list of requirements in a manifest file such as requirements.txt, where here again, you don't have any information about versions or hashes used. So this will not work and not guarantee either any reproducibility for your Jupyter notebook. My point is, Jupyter notebooks are by default not standalone. You cannot share a Jupyter notebook with someone else. It considers that it will run on a different machine with different dependency versions and using a different Python version. In fact, dependency management in Jupyter notebooks puts constraints on the author of the notebooks to provide a decoupled manifest file, like a requirement.txt or a pipfile.log, along with the notebook, so that the notebook users can install the exact same software stack that you used to develop the notebook. Dependencies are also a problem when you want to containerize your notebook. If you want, for example, to ship your notebook into a container and share it with someone else, you have then to make sure that your Docker file or container file will be able to adjust the dependencies accordingly. And finally, the consumers that receive a shared notebook also have to set up manually the correct environments, which can be difficult if no manifest file or any information regarding the environments in which the author developed the notebook is provided with it. And this is often the case with shared Jupyter notebooks. To summarize what would be the difficulties this creates for both authors and consumers, they should both create an environment to run the notebook in, ideally a virtual one that will not be polluted by any dependencies. They will have to install the dependencies, to create a kernel and update it every time they have a new dependency. And in addition to that, the author had to maintain a requirement file to allow others to get the exact same dependencies that the notebooks was developed with. What we are looking for is a solution that would help authors keep their dependencies and manifest files up to date and thus achieve reproducibility of their notebook. So earlier I introduced you Project Thoth. So now I will see how Thoth can actually help you manage dependencies in your notebook and get an optimal set of dependencies for your application. First, a few words about Thoth. So the main goal of Thoth is to help developers and data scientists create and maintain healthy Python applications. This project was started in 2018 at Red Hat Office of CTO, and now it is maintained by a team of 10 engineers and has had over 50 contributors. Thoth is a cloud-based recommendation engine for Python application, which is able to solve dependencies to their optimal versions using machine learning. Of course, Thoth is an open source project, so you can contribute, of course, if you want to, and involve yourself in the Thoth community and share your ideas with us. What Thoth does is that it provides an extension to manage dependencies in Jupyter notebooks via a Jupyter Lab extension. So Jupyter Lab, if you don't know, is interactive and extensible web interface to work with Jupyter notebooks. That extension for Jupyter Lab is called Jupyter Lab Requirements, and it allows you to manage your dependencies without even leaving it by storing all of the necessary dependency information directly in the notebook metadata. You can provide an optimized environment unique to each notebook by solving dependencies using Thoth's dependency resolution engine. So let's see what the user interface of Jupyter Lab Requirements looks like. So when you work with Jupyter Lab, you have your Jupyter notebook open, and typically it looks like this. And if you have Jupyter Lab Requirements enabled on Jupyter Lab, you will see this button called Manage Dependencies. So if you click on this button, you will have this menu where you will be able to add your dependencies with a button. In this notebook, for example, we import TensorFlow and NumPy. And I want to say that I want TensorFlow, for example, in version 2.2.0, and NumPy in a range of version from 1.0.0 to the latest version possible. So I will put the set of packages and constraints in the UI and save those dependencies. Now I will have this menu where I will be able to choose a resolution engine. So you can use the Thoth resolution engine, or you can use pipenv also, which is used as a backup to Thoth. You can also choose, if you have the Thoth resolution engine, a recommendation type, and we'll see later exactly what it is. But now we'll say that we want our dependencies to be resolved to the latest possible versions. And finally, you have this section with information about your environment, which is automatically filled by the extension. But if you want to, you can also modify it by hand. So here, for example, I developed my notebook using Python 3.8 in a RHEL 8 environment OS. So now that everything is specified, we are contacting Thoth's backend for advice, which takes typically a few seconds or minutes. And Thoth's backend is going to compute this fully pinned down software stack here with the latest possible versions I have specified, and send it back to us in the form of a log file. So now that we received the fully pinned out software stack, we are installing these requirements in a virtual environment, and this is done with a tool called micropipenv. And this tool has been developed within Project Thoth to install dependencies, and it can do sort of wrap around pip to convert requirements file like requirements.txt or pipenv poetry log files, for example, into a pip tools compatible outputs. So now we have our requirements locked and saved. They are installed. We also created a new kernel, and we can simply click to start working on our notebook. Everything is installed and ready to use. On the right side of your UI, you will normally see an option to have the notebook metadata, which is a JSON file. And here, as I said earlier, you will be able to see that your dependencies, as you specified them, so with the right versions, have been locked directly in the notebook metadata. And if you scroll down, you normally will see also your whole software stack with your direct and transitive dependencies and the corresponding hashes they have. So everything has been saved there. It's directly in the notebook. You can also have access Thoth's recommendation using Horus magic commands. So maybe if you know a bit Python, you're already familiar with magic commands. But if not, it's OK. So these commands basically allow you to do the same, but directly in the notebook cells to speed up the development of your notebook. So this is an example of the command that helps you lock your dependencies and outputs. But you can also do you can also perform those actions which are checking notebook metadata about dependencies with Horus check, but also converting pip commands to Horus commands to allow more reproducibility. You can also discover dependencies already exist in your notebook and create automatically a pip file and do a lot of other actions such as adding or removing requirements in your pip file also. If you take a look at the output for Horus check, for example, for checking for dependencies, you will have the following table with information about your projects, about the advisor ID, so the advisor ID you sent to Thoth, But also, for example, here I let this warning, which tells you that you forgot to set a kernel. So it will warn you that you have to run or set kernel to set a kernel for your notebook before performing this action. If you want to install and run Jupyter Lab requirements, you can get this extension from the Python package index PyPI by running pip install Jupyter Lab requirements on your machine. And if you want to use this extension, you can do so by running the Jupyter Lab command to open a local Jupyter Lab instance. And if you have Jupyter Lab requirements enabled, you will be able to run it as we saw just now. And now, what about containerized notebooks? Does any of you work with containers? Okay, that's a few people. So besides this extension for Jupyter Lab, we thought it is also possible to manage dependencies in containerized Jupyter notebooks using source-to-image. Source-to-image is also known as S2I, is a tool for building reproducible images, and it produces images which are already ready to run by ejecting an application source code into a container image, which assembles it into a new image. And Thoth provides minimal Jupyter Notebooks container images, which can be built on OpenShift, which is Red Hat distribution of Kubernetes, to manage dependencies using Thoth's recommendation, but also container images for other types of application by extending the functionality of some base S2I Python images to use Thoth services. Now that we have seen a few ways to manage dependencies in Jupyter Notebooks and to get an appropriate software stack using Thoth, you might be wondering, well, how does that work? How is this recommendation computed exactly? So that's what we'll see. The core component behind Thoth's recommendation is called the resolver. And the philosophy behind the resolver is to recommend the greatest and not the latest possible versions for your dependencies. When you install dependencies using pip or pipenv or similar resolver, the resolution process uses a backtracking algorithm, which will systematically solve your dependencies to the latest possible versions. However, this is not the case with Thoth's resolver, which uses reinforcement learning to solve dependencies in the cloud, therefore using resources from a cluster and not from the user's local machine. Thoth's resolver has 5 different recommendation types, which can adapt the dependency resolution process to user specific needs. Of course, the resolver can solve dependencies to the latest possible versions, but for example, it is also possible to configure the resolver to get the most secure possible software stack. The security recommendation type is particularly useful if you want to manage dependencies in applications which are deployed in the production environment, for example, because the associated set of dependencies will contain only versions that are free of known vulnerabilities. But for users developing programs where the focus might be on performance, for example, the resolver can be adjusted to performance recommendation type to get dependency versions which will maximize the performance of an application according to a user's hardware and software environments. An example of how we evaluate the performance of libraries by performing benchmarks between different versions by using those versions of libraries in different kind of performance scripts. So for example, it can be matrix multiplication, convolutional filters, or any kind of heavily computational operations. And then we can compare the speed, for example, of execution for different versions of, TensorFlow if you're using for matrix multiplication. The recommendation type for Thoth can also be set to stable if you want to get the most stable versions of packages, or to testing if you want to run software that can possibly be unstable. This recommendation type testing is more suitable for experimenting, and because other recommendation type can be more strict and not resolve any dependencies in this case. Thoth collects a set of requirements and constraints about dependencies, as well as the recommendation type for the resolution, and also information about the user's environments, such as the operating system and Python version used, but also if the application uses a base container image to run, has CUDA configured, or what type of hardware is present, and it sends back this information to a component that we call the advisor. The advisor is responsible for computing the optimal application software stack. It uses a knowledge database containing information about dependencies, and it dynamically constructs a resolution pipeline which is made of different types of customizable pipeline units. Those pipeline units make the resolution process optimized for each application and its runtime environment. So the advisor sends back a fully pinned down software stack, including the direct and the transitive dependencies, in the form of a log file, along with a justification to inform the user on why some dependency versions were added or removed from the resolution process, and to warn or inform about some package specificities. So what we observe in our knowledge graph. This observation include, among other things, information about the application stack, such as build time and runtime environments, but also about dependencies and benchmark of packages version performances. We also have information about application binary interface, CVEs for libraries, different kind of security analyzers, and also source code meta information. So now I want to talk to you about prescriptions and how they can help you heal your Python applications. So what we call prescriptions are in fact an example of configurable pipeline units that we use in Thoth resolution process. They are simply declarative YAML files stating how the resolution process should look like. And they are a way to formalize developers' knowledge about dependencies into units which are automatically consumed by the resolver to compute the software stack recommendations. So prescriptions are present on an open source GitHub repository under the Thoth Station organization, so that every developer with any knowledge about dependencies can help improve Thoth's resolution process. So now let's see an example of how a developer can create prescriptions from his knowledge. So here I took this issue from the Pillow repository on GitHub, of the Pillow library. And here we have this user who saw this issue, which was that Pillow 8.3 and NumPy are incompatible. So for example, you have this error when you try to run an application with Pillow 8.3 and NumPy. Type error array takes 1 positional arguments, but 2 are given. So we see that Pillow 8.3 and NumPy have API incompatibility. So what this developer can do, for instance, is create this prescription, which is a YAML file. And if you want to know exactly how to create the prescriptions, it's quite easy to do. It's something we have in our documentation. And so basically in this prescription or YAML file, you will find information about the packages that don't go together, their versions, the index that come from also. And you will have a warning which will be returned as a justification to the user. For example, Pillow in version 8.3.0 does not work with NumPy. And you also have the link to the justification, which is the issue that was open on the Pillow repository at the end, so that users can check how why Thoth exactly didn't allow to solve Pillow and Pillow 8.3 and NumPy during the resolution process. Some of the prescriptions we have are automatically created and refreshed on a weekly basis using Python package data from different sources, such as the Python package index, GitHub open source repositories, but also from publicly available datasets, such as the Security Scorecards datasets, which is created by the Open Source Security Foundation. This prescription can contain data about package popularity, non-vulnerabilities for some package versions, artifact size, for example, and all of this can be used during the resolution process to assess the reliability of a given dependency. So finally, let's see what are the conclusions we can draw from what we just saw. Managing dependencies in Jupyter notebooks has become significantly easier for authors because of requirements being locked and embedded directly into the notebook metadata with no additional file needed. Jupyter notebooks with embedded dependencies can be built using Jupyter Notebook source to image without any additional files either. And finally, notebooks can be shared as standalone units with an environment ready in a few clicks. Using Thoth to manage dependencies in your notebook both guarantees that your notebook will be shared in a consistent and reliable manner, and that your application will benefit from the best possible software stack according to its purpose. Finally, I would like to thank you and also encourage you to contribute to Project Thoth to help make Python dependency resolution better. If you have any question, you can ask them to me. I will be available right there. And so thank you very much.